This is a short demo of how to add an OpenID Connect client to Keycloak, where the client has service accounts enabled and uses Signed JWT authentication. We start by visiting the Keycloak administration console. In our realm, we choose Clients and Create. We'll give a client ID here that's meaningful to us and ensure that the client protocol is OpenID Connect. Once we save, we're at the initial settings screen for our client. We're going to set the access type to confidential. That enables a couple features down here that were not present when our access type was public. We'll turn off the OAuth flows that would allow us to authenticate users, and we'll turn on the OAuth flow that enables service accounts, which in the spec, in the OAuth 2 spec, is called Client Credentials Grant. We'll scroll down and make sure we select Save. We'll know we hit Save because we now have a Credentials Settings tab available to us, which we'll visit in just a moment. But first, let's take a quick trip to client scopes. We want to ensure that the tokens issued to this client will have the scopes that we want. And that really depends on what the client's doing. For Stigman Watcher, we'll add these two scopes. And we also want to ensure that the tokens issuers will have a roles claim. And so that's needs to be present as well. Now let's go visit the Credentials tab. If we're going to authenticate using client ID and secret, then we're essentially done, because this is the client secret, this is the client ID, right? And you can regenerate the secret at any time. But we want to do signed JWTs because we want to use public key cryptography to authenticate, which means Keycloak needs to know our public key, or the public key of the client. We can import an existing public key by selecting this button, or we can generate new keying material, which is what I'm going to demo right now. So let's generate new keying material. The private key and the public key are going to be put together into an archive. We're going to choose PKCS12 as our archive. It's more widely supported than the Java key set. We have to provide a key password and a store password, although in practice only the store password seems to actually be applied by Keycloak. When we select Generate, we have an opportunity to save this PKCS12 archive to disk. So that key material was generated, and Keycloak retained the public key. So that's now in the form of an X509 certificate, which is available to Keycloak, as we can see. The private key, though, is kind of trapped in this PKCS12 file. And I say trapped because most clients, like Stigman Watcher, want access to a PEM-encoded private key, not to a PKCS12 archive. So a quick way to deal with that, here's the directory where we stored our PKCS12 archive. A quick way to deal with that is to extract the private key using tooling like OpenSSL. So the OpenSSL tool is available on most Linuxes, pre-installed, and it's available for Windows rather widely available. We're going to issue this command, OpenSSL PKCS12, with an input file of our PKCS12 archive. And we'll indicate that we do not want certificates from this. So we're going to run this command against the PKCS12 archive and remove the certificates, and then redirect the remaining output, which will be a private key, to this file, private key PEM. When I enter that command, I'm being prompted now for the store password. It's called the import password here. So that's the password we provided to the store. And now, since that succeeded, we can extract the private key, and now we're being asked to provide a passphrase that will protect the private key, encrypt it. So this is not the same as the key password you did in Keycloak. It can be the same, but you're entering it fresh here. You're actually encrypting private key.pem. So if we take a look, we now have private key.pem. And if we take a quick look in it, it's a PEM encoded encrypted private key. It's actually an elliptical curve key. And that's the file that would be needed that we would need to provide to a utility like Stigman Watcher if we want to authenticate using signed JWT. And we'll look at how there's other video that deals with how to configure Stigman Watcher to use this key material. But essentially, we're done now on the Keycloak side. We've created our client, and we have keying material so that we can do signed JWT authentication. Thanks for watching. That's all we've got.